Hello everyone, my name is Rajput Sujit. I am from Group C. In our group, we are four members: Rajput Karan, Rathod Ronak, Prajapati Shubhas, and me. Today, I am going to explain you the three-phase induction motor. In this presentation, we are going to cover 9 topics, which are introduction of induction motor, rotor of induction motor, torque slip characteristic, torque speed characteristic, effect on rotor resistance on TS characteristic, type of starter. In this we have 4 types of starter. Then speed control of induction motor, equivalent circuit of induction motor, and last our topic is isolated induction generator. So to start with the introduction, first of all we have to understand few basic things. Let's start with the word motor. When we heard the word motor, the first image comes in our mind is that a machine which uses electricity and produces some kind of mechanical work, or we specifically say that the rotatory kind of mechanical work. This is correct, but we are studying the three-phase induction motor. So the three-phase induction motor is the motor which uses three-phase AC supply, and the AC supply are 120 degree apart from each other in a phase. In a phase. So this is the basic difference between the normal motor, or we can say DC motor, and the three-phase induction motor. Three-phase induction motor, and also we have to understand the basic apparatus of the induction motor, or yes, we have to understand the basic apparatus of the induction motor. There are two main components of an induction motor. First is the stator, and the second is rotor. Stator is the stationary part of the induction motor, and three-phase winding is fed to uh, the three-phase supply is fed to the stator, and the rotor is the rotating part of the motor, and it generate a mechanical energy. When we fed three-phase supply to the winding of the stator, it generates a magnetic field. The magnetic field is in rotating in nature. Therefore, we called RMF, and the magnetic field is generated because of the Faraday law of electromagnetic induction. Now let's understand the operating principle. The the induction motor works by converting electrical energy to mechanical energy via a magnetic field. AC current in the stationary coil creates a rotating magnetic field RMF that we have discussed. When we fed three-phase AC supply to the stator, then RMF, the rotating magnetic field, is generated inside the stator because of Faraday law of electromagnetic induction. Then torque generation. Torque generation. Where is torque generation? The RMF cuts the conductor of the rotating part, the rotor, including a voltage and inducing a voltage and current. The interaction between these current and the magnetic field produce the force, Lorentz force, and thus the mechanical torque that turns the rotor. So when the rotating magnetic field of the stator interacts with the rotor parts, or we can say when the RMF cuts the winding of rotor, the current and voltage induced inside the rotor because of Faraday's law, and the interaction between current and the magnetic field produced by the rotor, which interacts with the rotating magnetic field of the stator. It generates force, which is known because of Lorentz force, and this imbalance force generates the torque inside the rotor, and rotor starts to rotate. Then we have synchronous speed. Synchronous speed is the speed at which rotating magnetic field rotates inside the stator, and it is represented by ns, and its formula is 120 f by p. Here 120 is obviously a constant, f is the frequency, p is the pole of induction motor. Then we have slip. Slip is the relative speed between the synchronous speed and the rotating speed of a rotor. And the slip must be uh, uh, less than the synchronous speed. The slip must be less than the rotating magnetic field speed, or we can say synchronous speed. Slip is denoted by S, and it is calculated in percentage. Here ns is the synchronous speed, is n is the rotor speed, and ns also the synchronous speed. Then we have our next topic is rotor of induction motor. Rotor, there are two types of rotor. First is squirrel cage, squirrel cage, and the another is slip ring or wound rotor. Based on these, rotor induction motor are divided into squirrel cage induction motor and wound rotor induction motor. So let's understand the squirrel cage induction motor. The rotor is permanently shorted, means electrical energy cannot be taken out of the rotor, and all output is taken from the mechanical domain. So in a squirrel cage induction motor, all the rotor is permanently shorted and output is taken from the mechanical domain. Then we have wound rotor induction motor, or we can say that slip ring induction motor. This type allows energy to trapped out from either the rotor's electrical domain or mechanical domain. Here are the image of squirrel cage induction motor, and this is the image of wound rotor, or we can say slip ring type of rotor. Then we have our next topic is torque slip characteristic. So in this topic we are going to understand how slip affect the torque of induction motor. So in this we have four cases, and we also understand this graph over here. So these are the four cases of torque slip characteristic. Let's start with case number 4. At slip is equals to 0. At slip is equals to 1. Slip is equals to 1 means when the motor is at stationary state. A stationary state, then then the torque generate inside the motor is starting torque, and it is highly depend on the rotor resistance. Here in the graph we can see that this is the starting torque. Here for R12 is like that, and R22 it is like that, R23 it is like that, and so on. Then we have next stage at slip is very slow, or we can say that at that the rotors just start to rotate. So the relation between torque and slip will be torque is directly proportional to S, and the result of it is torque increase almost linearly with the load. That we can see that in the graph also. Here the torque, here the starting torque after just the rotor start to rotate, then it linearly increase in all of these three graphs we can say, and torque is directly proportional to S. This is the point where the T max at the point uh, where the maximum torque is attained. And now we have at high slip, the This condition arises after this point when the maximum torque is attained. So the relation between torque and slip is inversely proportional to each other, which results the rotor frequency and losses are high. And this, and after this we have s is equals to 0, that means torque is equals to 0. This condition at which we can say that rotor, the speed of rotor and the synchronous speed both are same, which result torque 0, and induction motor cannot run on this on the synchronous speed. So this portion of the graph here, after the uh, t maximum here and here and here also, it is just theoretically and it cannot be attained practically. Then we have similarly torque speed characteristic. In this we also have three cases, and in this we are understand that how speed affects the torque. Similarly, in this also we have case 1 in which the starting torque case, when the rotor is at stationary and the slip is 1, this is the starting torque. Then we have case 2 when the rotor is about to is running and the slip will be increased and torque will be decreased here. After this we have case number 3. It is as it is of the previous case, but in form of, here we understand in form of slip, here we are understanding in form of speed. The both graph are normally the same, but here just it start from the this side and it is start from that side. This is all. Now another topic, our next topic is effect of rotor resistance on TS characteristic. What is rotor resistance? That mean if we increase the resistance of a rotor, then what will be effect we get on the torque TS characteristic, or we can say that torque speed character curve. Increasing the rotor resistance fundamentally change the shape of torque speed curve. uh, Torque speed curve, when we increase the rotor resistance, it changes the this curve, that this curve changes, as we can see that in this image, when the rotor resistance is R2, then 2R2, then 4R2, then the curve we can see that the curve is constantly changing. This is also changing, this is also changing, this line is also this line also want to say this thing similarly. Then and the starting torque increase means, here we can understand with this image. Let's for example, this art at R2, the starting torque is like this much, and at 2R2 the starting torque is like this much, and 4R2 the starting torque also increases. So the first point is starting torque increase. The maximum torque value remains same, but the slip at which it occurs increase. Here we can see the point is, uh, so where what the point is, the maximum torque increase, maximum torque will remain same. Okay, so here we can observe see that R2 the maximum torque is attained first, then 2R2, then 4R2, but the attending of maximum torque of all these resistance are same. But and we also understand that with the increase of the rotor resistance, we can increase the operating zone of the rotor and the last point is high resistance leads high losses and decrease the efficiency. this technique is mainly used during the starting of wound rotor induction motor to achieve high torque, after which the external resistance is removed. This point wants to say that uh, with increasing a torque we have two benefits. That the first, we can increase the torque, we can increase the starting torque, which is helpful for the heavy machineries like the crane, in which we need the starting torque. Therefore we increase the rotor resistance, we can get the starting torque increase. And the operating zone of the motor is also increased. But due to increase of rotor resistance, there are the losses, that mean in form of heat, it will increase, and the overall efficiency of the motor will decrease. So this method is only used when we have to have heavy working machines like crane and or high torque machines. So we use this method, but after attending high torque we remove this circuit. uh, and this is the effect of rotor resistance on TS characteristic. Then we have types of starter. In this we have four types of starter, which are direct on line starter, DOL starter, auto transformer starter, star delta starter, reactor starter. So let's understand the DOL starter, or direct online starter. Direct online starter means definition, or DOL starter connects the motor directly to the full supply voltage. In DOL type of starter, we directly connect our motor to the supply. When it switch on, full load is applied to stator, the rotor starts instantly. The motor starts instantly and reaches full speed quickly. So in this DOL starter, when because we have supplied our we directly supply the power to our motor, so the rotor start instantly and reaches full speed quickly. Advantage: it is easy to install and operate. Disadvantage: high starting current, suitable only for small motors. The disadvantage are important because high starting current, as we know that when when the motor is at stationary, the slip is is 1, so it consumes more electricity. Therefore high starting electric current, which leads the power loss, and suitable for only motor below 5 horsepower. 5 horsepower. That means this method is only suitable for a low horsepower motors. Then this is the circuit diagram of DOL starter. Here is the motor and the windings over all there. And then we have auto transformer starter. Auto transformer starter reduce the starting voltage using a transformer and gradually increase in it as motor speeds up. Working is at starting, motor is connected to reduce voltage tap of transformer. As speed increase, full voltage is applied. In auto transformer we use the auto transformer, and initially we supply the low current, but initially we supply the low current and initially we supply the low current and increase the speed. Low current Initially we supply the low current, and working is motor is connected to reduce tap of transformer. Advantages are reduced starting current, high torque per pair of supply current suitable for large motor. Disadvantage: low power factor, required more space. This is the circuit diagram of auto transformer starter. Star delta starter. uh, a star delta starter, the motor in starter connection and the changes to the delta connection after reaching the speed. In this form, we start we initially make the connection like the star to reduce the voltage, but after attending for speed or reaching to the speed, we change the configuration from star to delta. uh, Working the working in this starter are in two steps. First is motor start. Each phase reduces voltage. That means when motor start, the star connect star is star star form of connection is provided, which reduces the voltage by 1 by 3, and after reaching the 80% speed, then then after motor attempts once the 80% speed, this the connection switch to delta. Advantages are reduce advantages are reduce the current of by 1 by 3 of DOL, means direct on load starter, and inexpensive. Disadvantage: starting torque is reduced by 1 by 3 of full load torque. Only motor with delta rated winding. Only for the motor with delta rated winding. Here is the circuit diagram of star delta starter. And then reactor starter. A reactor starter uses reactor inductor in series with the motor to limit the starting current. The reactor reduce voltage at start. As motor speeds up, the reactor is gradually cut out allowing full voltage. In this starter, we use the inductor, and after motor attains the speed, we removed it. uh, uh, the because of due to this thing, we get the advantage like smooth start, better voltage regulation, simple and effective for medium motor. And disadvantage of this starter is voltage drop across the reactor, reduced torque, not suitable for heavy load starting. Then we have this is the uh, diagram of reactor starter. And now we have another topic: speed control of induction motor. First of all, we have to understand why do we need to control the speed of induction motor. Because there are various machine in our day-to-day life, which we have to use different ways. For example, if for example, the fan, we need to use it sometimes at high mode, or sometime at slow mode. Therefore the we have to change the speed of the motor, steep speed of the blades. And we know the our fans are the induction motors. Therefore, which are definition to speed control means changing of speed of induction motor to suit the required operation, either increasing or decreasing it is as needed. Method: there are two ways to control the speed of motor. First is by the starter, with the help of starter, or another is the with the help of rotor. First is by changing supply frequency of the starter, and by changing supply voltage of the stator, and by changing number of poles of the stator. Then we have rotor control method, in which we have adding external resistance in the rotor circuit. Then using cascade connection, uh, and by injecting EMF in rotor. Then another topic is our the equivalent circuit of induction motor. Equivalent circuit. First of all, we have to understand why do we need the equivalent circuit of induction motor. There are mainly two reasons. First, by if we know the equivalent circuit of induction motor, it is very easy for us to determine the behavior of the induction motor. And second, the equivalent circuit of induction motor is very likely to uh, the transformer. To obtain the equivalent circuit of induction motor, we have we have four steps. Four steps that yes, we have four steps. First, we considered motor is at standstill. That means slip is 1. So the the motor circuit is identical to the transformer. It is like a transformer with a secondary winding is shorted. It is written over here. It is like circuit is identical to a transformer with shorted secondary. Second, we have step 2, when the motor is in a motion. As we know, when motor in a motion, or we can say rotates, all the parameters, that means E1, if we consider E1 is the EMF induced by the rotor when it is at standstill, changes to E2, at EMF induced in EMF induced in rotor when it is rotating. So E1 changes from E2, so the value of E2 is equal to S into E1, where S is the slip, and the rotor reactance also changes, is equals to S into X2, because the frequency is Fr. That means rotating frequency is equals to frequency product of synchronous frequency and the slip. Then we have step 3. In this step, we transfer we transfer impedance of rotor to stator side to obtain the current equation. And in step 3, we the rotor impedance referred to stator to eliminate the ideal and simplify the ideal transformer and simplify the circuit. The rotor impedance Z2 is referred to the stator side. The rotor current I2 is expressed. So this is the equation of rotor current. Here it is E1 R2. R2 is the rotor resistance, referred rotor resistance to the stator. X2 is the referred reactance to the stator, and E1 is the EMF. Then step 4, the equivalent circuit. Equivalent circuit, the crucial result is that the rotor winding resistance is molded as slip dependent resistance R2 by S in series with rotor leakage reactance X2 referred to stator. This step also describes this thing in this slip dependent. When we transfer the rotor resistance to the stator side, then the overall rotor resistance is dependent on the slip, and the X2 is not. Then this R2 by S is component split into two parts. First is R2, the in form of copper loss, and R2 1 minus S upon S in form of reactance that represent the mechanical power developed. Then we have, this is the equivalent circuit of induction motor, three-phase induction motor. and isolated induction generator. An isolated induction generator is an induction machine that generates electricity without grid connection. It works independently. Working principle: when the rotor speed is greater than synchronous speed and the capacitor are connected to the stator terminal, the machine generates AC voltage by self excitation. Advantage: relative cheaper and low maintenance. It runs parallel with without hunting. So basically uh, the isolated induction generator and generator induced machine when rotor speed is greater than synchronous speed. This is the circuit diagram of isolated generator. Here are the link. Here are the provided link, and thank you for listening this lecture. Thank you.